Hello everyone, my name is Alexius Octavio Yudiono with a student number of 25021252204. Right now I'm going to explain to you a simple way of making an AI. But first, we must know about what is AI. So, AI generally can be split into three parts. It has an input layer, it has a hidden layer, and it has an output layer. The input layer is a part of the AI that is receiving an input from data in the form of either number, picture, videos, anything else. The hidden layer is the part of the AI that handles the math calculation with a simple calculation which is weight, hence the W, and the X, which is the input. And then the output layer outputs the calculation from the hidden layer. Even in ChatGPT or Gemini or Cloud, all of its neurons basically use the same simple equation, which is input times weight plus bias. After getting the output, it compares with the intended value and changes with the weight and bias to fit those values. And you guys probably know the equation that we use all the time in the high school, which is y equals mx plus b, and that is what we are going to train today. This is the stochastic gradient descent. This is how they basically compare the output and the intended output of the AI, and then using the optimization algorithm to make the weight and bias either smaller or bigger. This is the architecture of the code that we will make today. Since we are going to use only one neuron, you can see that the total parameters is 2, which is the weight and the bias. And this is the target of what we are making today. We are going to make the line or the AI guess to fit the data point as close as possible. Okay, so basically this is what I've been preparing. Okay, so first I'm going to explain to you about the coding that I've done here. So basically at the top we imported a bunch of things. The TensorFlow is the library that we use for the AI. The NumPy is just a simple calculation library. Matplotlib, this two Matplotlib is used to create graph in the Python language. So as you already learned in high school, usually the X represents an input, which is why we have a series of input here that we make a list, and the Y is a series of output. Here the intent I intend to make the Y, you can make an equation like this, yeah. The Y is equal to times X minus 1. Hence, if we put the minus 1 here into the X here, we will get minus 2. And if minus 2 is subtracted by 1, we get minus 3. And so on and so forth until we reach the input of 9, which will make it 17. Now, the next thing is the class. What is this? This is for drawing the graph, basically. What you need to understand in this class is basically when the epoch or the iteration is divisible by 10, we take the weights, we take the bias, and then plot it on the graph. That's it. Now, X is here we initialize the model using tf.keras.secondShow. Inside the second shell, we make the f.keras.layers.dense. Now, what is dense? Basically, dense is like you make the neurons dense. That is why here we can see its unit, right? We can put it how many numbers we want. We can put it like 10 or 100. It depends on the input and the output. If you would like, for example, want to make an LLM like an ChatGPT, you will make many more neurons. And as you can see right here, you can see that this is the neurons, and this is another neurons in a different layer, and this is another neuron in a different layer. Then if you want to create it like that here, then you will do it like this. We just copy this, and then make, so this is basically the first layer, this is the second layer, and this is the third layer. So we can make this 10 or 100 depending on the complexity of the task. But for now, let's just stay with the one neuron. Next is the compile. So compile is basically you put it all together, what the model is using the optimizer, and I will show you the optimizer right here. The optimizer, as you can see, is the stochastic gradient descent, or SGD. This is an optimization algorithm that minimizes the losses. Here you can see the learning rate is 0.01. So basically every step the optimizer, the model makes, it must reduce it 0.01, either up or down. And the loss is mean squared error. Well, what this means is that you take the average of all the inputs in the batch, which is the mean, and then square it to get the error. And this is used to compare the output that the model spit out at first and compare it with the output that we intended. And that model fit is basically putting the input, the output, and how many epochs you want. And this is just for the drawing of the graph. And verbose one means that you want to see all the relevant information in the concept. And this piece of code is basically just to draw the graph. So let's run it. Okay, so first let's run it. We can see that this has started to compile, and boom, you can see that after each epoch, you can see that the losses is decreasing, and as it's decreasing, it's starting to learn that the y as we intended is 2x minus 1. Hence, we can see that the line is basically trying to be at the center of the dots. And after around 800 epochs, we reach our intended equation, y equals 2x minus 1. Okay, so that's basically it. And if you guys want to learn more, oh wait, here's the summary. Okay, so one neuron AI can solve the equation y equals mx plus b pretty easily, but if you want to solve more complex problem like classifying image or videos, the AI will need to millions of neurons stacked into something that we call deep learning, and this will be used for image classification, LLMs like ChatGPT or Gemini that we all use and love. And if you want to learn more, you can join Bangkit Academy. with the machine learning course, and in it we will learn deep learning AI, machine learning specialization at coursera.org. If you want to learn it on your own and you don't want to join the Bangkit Academy machine learning course, you can just sign up on Coursera. It's not free, but I guarantee it's worth it. See you.